Welcome back to Spring into Math 7. I'm Mrs. Campbell, and today we're going to be talking about dependent events. Let's get started. Let's start by looking at a definition. What are dependent events? So when events depend on each other, they're called dependent events. So suppose you randomly draw a card from a standard deck, and then you randomly draw a second card without replacing the first. Now the second probability is now different from the first. The first probability is 1 out of 52, because there's 52 cards to start with, and then the second probability would now be 1 out of 51 because we didn't replace the card. Okay, it says right here, this is because you kept the first card you picked. So to find the probability of two dependent events, we multiply the probability of the first event by the probability of the second event after the first event occurs. So it's pretty simple actually, it's just multiplication. Here is an example. So suppose you're dealt 2 cards from a standard deck of 52 cards. What's the probability that they both will be face cards? So we're going to let A equal that the first face card chosen, and we're going to have B represent the second face card that's chosen. So remember, there's a jack, queen, and king, 3 total face cards in each of the 4 suits: clubs, diamonds, hearts, spades. So the total number of face cards in a deck of cards is going to be 3 times 4, so that would be 12 total face cards in a standard deck. All right, remember, I'll put these here so we wouldn't forget. A equals the first face card chosen. B is the second face card chosen. Remember, we have 12 total face cards and 52 total cards. So the probability of A, or the first face card chosen being the first card chosen being a face card, is 12 out of 52. Okay, then the probability of B, or the second face card chosen being a face card, the second card chosen being a face card, is 11 out of 51 because remember, one of our cards has been removed. So the probability of A equals the probability of drawing a face card the first time, like we said, and the probability of B is the probability of drawing a face card the second time after you've already removed the first face card. Again, remember, now the total number of cards is now 51, not 52. So, okay, put our probability back up here again for A and B. And now what we have to do is just calculate the probability of both. So we've got our first draw here, 12 over 52, and our second draw here, 11 over 51. And then all we have to do is multiply them. So to find the probability of A and B, we multiply these two and we get 132 over 2,652. And then simplified, we would get 11 over 221. Let's look at another example. So a bowl contains 12 red marbles, 5 blue marbles, and 13 yellow marbles. So we're being asked to find the probability of drawing a blue marble and then drawing a yellow marble. So we're going to let A equal the blue marble being chosen first and B equal the yellow marble being chosen second. And then let's just quickly write down the total number of marbles we have is 12 plus 5 plus 3, which we got here out of the question. So we have a total of 30 marbles. So the probability of event A, or of a blue marble being chosen first, is 5 over 30, 5 out of 30. And the probability of B would be 13 over 29 because remember, one marble has been removed. All right, continuing on. So the probability of drawing a blue marble first, we know is 5 out of 30. The probability of drawing a yellow marble after we remove the blue marble is 13 out of 29. Then all we have to do is multiply both the probabilities. So the probability of A and B is 5 over 30 times 13 over 29. multiplied, we get 65 over 870. And then once we simplify that, the probability of drawing a blue marble first and then drawing a yellow marble is 13 to 174. All right, everyone, that just about does it for this quick lesson. Thanks for joining us. We'll see you next time. Bye-bye.